Everyone. Welcome to lesson 9.4. Here's your objective. I will be able to determine how changes in dimensions affect perimeter and area. Now I know we haven't talked about perimeter too much, but it's easy to pick up on. Okay, so first of all, the perimeter is how far all the way around, okay? So let's just get the perimeter and area of this shape, and then we'll change the dimensions. If we double the dimensions, we'll see what happens to our perimeter and area. So these sides are equal, so this would be a 4 as well, and these sides are equal. That'd be a 5. So the perimeter of this shape, let's say they were meters, would be 5, 10. 10 plus 8 would be 18 meters. All right, so right now we are at 18 meters for our perimeter. Perimeter equals 18. Now what about the area? Who can remember how to find the area of a parallelogram? Yes, you. Oh yes, you're right. It is base times height. So I have a base of 5, a height of 3. The area of this parallelogram equals 15 meters squared. All right, so there we go. Now, what would happen if I were to double these dimensions? So I'm not going to just necessarily double my perimeter and area. No, because the whole shape is changing, become bigger. It's going to be congruent, all right, but the sizes aren't going to be equal anymore. So if I were to double the dimensions, I'd have 10 for a base, I would have 6 for a height, and I would have 8 for my sides. So let's check out the perimeter now. 8 plus 8 would be 16, 10 plus 10 would be 20, and 20 plus 16 would be 36. So actually, my perimeter did double. 18 became 36 meters. How about the area? Let's see if the area doubles from 15 to 30. Let's see if we can find a difference there. All right, my area is once again base times height. 10 times 6 equals 60. So my area would have been 60 meters squared. Now, isn't it interesting to see that when we double the dimensions, the perimeter actually doubled there? Is it a coincidence? I don't know. We'll have to find out with a different shape. But the area did not double. The area actually quadrupled when we doubled the dimensions. So that's kind of interesting. Maybe because it has something to do with the squaring factor, or that it's a 2D shape and the perimeter is just one dimension. I don't know. Think about it. It went from 15 to 60. That's kind of interesting, and how the perimeter doubled when we actually doubled dimensions. Okay. Let's try it out with a triangle. All right, first of all, let's find the perimeter and area. Now, it's tough to see there. I don't know if you could see it, so I might have to write it in for you. But let's find the perimeter and area of this triangle right here. Once again, we'll just call them meters, but I have a length of 5, a length of 5, a base of 2, and a height. You can't really see it. Can you see it now? A height of 4. This is my height right through here. Okay. So, perimeter would be 5 plus 5, which equals 10, plus 2 more, which equals 12. We'll just say 12 meters. My area is now half the base times height. So base is 2, height is 4. If I plug in my formula, area equals half of 4 times 2. All right, 4 times 2 equals 8. Half of that is 4. My area is 4 meters squared because it's a two-dimensional figure. All right, so this is my perimeter and area for that shape right there. Now, what would happen to the perimeter and area if we tripled the dimensions? So I'm guessing the perimeter, I could be wrong, I'm guessing the perimeter, if I triple it, will be 36 for this shape right here. All right, let's go ahead and do the perimeter first. So if I triple the sides, 5 tripled would be 15, 5 tripled would be 15, and 2 tripled would be 6. Let's add a perimeter. 15 plus 15 equals 30. 30 plus 6 equals 36. So my perimeter on this shape equals 36 meters. And look, 12 tripled is 36. So once I find these, it looks like instead of adding up all my dimensions, I could just triple that number for perimeter. Let's see what happens with the area when we triple the area here. Okay, so I didn't do my height yet, but 4 tripled is, you got it, 12. So remember, the area of a triangle is half the base times height. So plug in my little formula here. Area equals half of my base, which is 6, times my height, which is 12. Okay, let's do it out this time. So 12 times 6. We could do it in our head, but let's just do it out. 6 times 2 equals 12. 6 times 10, or 1, equals 6 plus 1 more equals 7. We're at 72. Now I have to find half of 72. So I could either divide it by 2 or multiply it by a half. Let's divide it by 2. How many times does 2 go into 72? 2, 4, 6, 3 times. Minus that, get my 1, bring down my 2. 2 goes into 12, 6 times. So my area is also 36, but it's meters squared. Oh, that's interesting. All right, because 4 tripled is not 36. 4 tripled is 12. All right, but then 12 tripled is 36. So it's like triple twice. I'm trying to find a correlation there or a pattern or some sort. I don't know. Maybe we'll talk about it and discover it in class. Maybe you see something right now that maybe I don't, or maybe I do. Who knows? So it's interesting, when we change the dimensions, we tripled these dimensions, and our perimeter actually came out triple. But when we did the area, we tripled the same dimensions. The area did not triple. It actually was, well, it's 4 times 9, really. So it got multiplied by 9 to get to 36. So some interesting things here. You have a couple of questions to do for me. And we'll get to that after I erase all this. All right, so you have a shape right here. I think you could see it. You have a 4 centimeters for a height. You have a 5 centimeter base, and you have another side, which is 6 4/10 centimeters, or 6.4. So you have 2 questions. If you can't see it too well, I'll read it out loud. What would happen to the perimeter if each side length is doubled? So you have to double the 5, double the 4, double the 6.4, and tell me what the perimeter would be. And see if you notice any patterns or something. Write down a sentence or 2 about what you notice. Then B, what would happen to the area if each side length is tripled? So now for B, you triple the 5, you triple the 4, and you triple the 6 4/10, and find the area now for B. And see what you can find out. Give me a sentence or 2 about the difference. So you might want to, actually probably should, for A, find the original area, or sorry, the original perimeter, and B, find the original area. All right, good luck, and I'll see you when I see you.